Today we will discuss how manually we can plot a graph, okay, using a graph paper. So first what you need to do, so you can see this is a graph paper, okay, so this is a graph paper. So there are some kind of small boxes are there, okay, so we have to plot, okay. So what you need to choose, first you need to choose what the axis, okay, so axis, so there are two axes, x-axis and y-axis. So what will be the x-axis? X-axis will be your independent variable. So x-axis is independent variable, okay, and for y-axis it will be your dependent variable, okay. As for example, we want to plot the verification of Ohm's law. So there are some kind of data, that is applied voltage versus current. So in this case your independent variable is applied voltage, since you are applying some kind of voltage, and for that corresponding voltage you are getting some kind of current. So your independent variable is applied voltage and dependent variable is current, okay. So we will choose x-axis and y-axis. So first draw the axis. So this is your x-axis, okay, and this is your y-axis, okay. So x-axis, we have to write the name of the axis. X-axis, that is applied voltage, and one should also remember you need to write the unit also, since unitless quantity is meaningless, okay. And for y-axis it is current unit, okay. So look carefully, I want to plot this thing. So I need to remember this maximum things, okay. So look at this maximum. The maximum is for applied voltage it is 12, and for current it is 40 milliamp, okay. So if I want to plot, so look carefully, it is 1 2 3 4 5, it is 10, it is 12, okay, and 40 is 10 20 30 40. So if I plot using this scale, it will stop here also only, okay. So the graph will be this one. So there will be lot of error if you do like that. So what you need to do, you need to expand the graph, okay, and the expansion should be in such a way so that 75% of this graph should be occupied. So we need to choose the scale. We need to choose the scale of this x-axis and y-axis so that this data will be fitted throughout this graph, and 75% of this graph should be occupied. So it is some kind of a zoom. So you can zoom out this thing, okay. So we need to choose the scale. So in order to choosing the scale, we need to consider this maximum value, okay. So suppose we want to fix maximum value here, 12 here, okay, and this 40 here. So this graph will be throughout this whole page. So look, here it is 10 20 30 40, okay, 40 50 60 70 80 90 100 110 120, okay. Suppose if I want to fix here, that this is my 12 volt, okay. So this is my 12 volt. This is my 12 volt means what? That means 12 volt means here 120 divisions are there. So 120 division is equals to your 12 volt. So your 1 division is equals to 12 by 120. Okay, so that is your 0.1 volt. Okay, so this is the scale for x-axis. So we need to write scale here. So one smallest scale division is equals to 0.1 volt, okay. Similar thing, we will choose this y-axis also. So for y-axis, look carefully, this is the maximum value is 40. So we will choose 40. So look carefully. So 40. So if I choose here, this is my 40. So your graph will be expanded. It will be some kind of zoom. So I want to choose it. So suppose that is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. So 100, 110, 120, 130, 140, 150, 106. Suppose let's say it is your 40 milliampere. So for y-axis, okay, so for y-axis we are choosing the scale, okay. So for y-axis that is 160, okay, 160 division is equals to your 40 milliampere. So your one division is equals to 40 by 160, that is 0.25 milliampere. So for y-axis this is the scale. So I will write one smallest division, one smallest scale division. So this is your x-axis, this is your y-axis. One smallest scale division is equals to 0.25 milliampere. Okay, so we have choose this scale choosing is over. So next thing we will plot this data using this scale. Okay, and so what you need to do, so you need to write here. Okay, so what is the value of this? So in x-axis it is your one smallest division is equals to 0.1. So for 10 it is 1 is 10 into 0.1, that is 1. So it is your 1 volt, it is your 2 volt, it is your 3 volt, it is 4, it is 5, it is 6, it is 7, it is 8, it is 9, it is 10, it is your 11, it is 12. Similar thing for y also. So what? That is your one smallest division along y is 0.25. So 0.25. So for 10 it is 2.5, it is 5, it is 7.5, it is 10, it is 12.5, it is 15, it is 17.5, it is your 20, it is 22.5, it is your 25, it is 27.5, it is 30, 32.5, it is your 35, it is 37.5, and it is your 40. Okay, so look at this, that is 0 0. So 0 0 is this point. Okay. So that you are not confused. Okay, so what you need to do, you can encircle it. Okay, so this is my one of the point. Next thing is 1.5 and 5. So 1.5 along x-axis it is 1.5, so it is 1, this is 1.5, and y-axis it is 5. 5 means that scale that 5. So that is, this is along x-axis it is 1.5, along y-axis it is 5. So this point. Okay. Similarly, it is 3 and 10. 3. This is 3 and this is 10. So we will go 3 x-axis and 10. Here it is 10. Okay. So 3 and 10. Next thing is 4, 15. So 4. This is 4 and 15. 15 is this one. Okay. So this is 12.5. This is 15. So 4, 15 is this one. Next thing is 6.5, 20. That is 6. That is 6.5. And here it is 20. This one is 20. So 6.5 and 20. So yeah, this one 6.5 and 20. This is 6.5 and 20. Next thing is 8 and 25. 8 and 25. This is 8 and 25 is here. Here it is 25. So 8 and 25. That is the 8 and yeah. This one is 8 and 25. Next thing is 9 and 30. Okay. So 9 and 30. So in along x-axis it is 9 and 30 is this one. 9 is 9. Okay. 9 and 30. This one. Okay. 9 and 30. That is 10.5 and 35. 10.5. This is 10. This is 10.5. 10.5 and 35. 35 is this one. So 10.5 and 35 is this one. Okay. and last reading is 12 and 40. So this is your 12 and this is your 40. 12, 40 is this one. Okay. So this data, you are plotting this data in this thing. This is called some kind of scatter plot. Okay. So you can see that all the data points are not in. You draw a straight line, so all are not in a same line. Okay. So you need to draw in such a way so that this maximum of these points should be along a straight line, and no point is very far from this point, and some kind of a biasness. So you should choose the straight line in such a way so that it is no biasness is there. Biasness means what? If I draw a, like in this side, look carefully in this side, so all data points are along this side. So that means in this side there is no data point. If you plot in this way, okay, if you plot in this way, if you draw this thing in this way, so your maximum data points are in this side, but there is no data point here. So, but if you choose in this way, so that it is almost like a center of mass of this graph. Okay, so you need to choose in such a way so that no data points are very far from, and it is not other things are very close to each other. Okay, so you need to choose at the average. Okay, so at the middle of this, suppose you can choose the graph in such a way so that these data points are left side, some data points are in left side, and some of data points are in right side. That is, we have to choose at the middle. Okay, and there are one more thing, so that is called least square fitting method. So we will not discuss here least square fitting method. In least square fitting method also we can nullify the error. Okay, so if the scale is your transparent, then it is very good, but my scale is not transparent, so I will choose. Okay, so I am fitting this. Okay, so look carefully. Yeah, so almost this is okay. So this is your fitted line. Okay, so this is your base. Look carefully. So some data points are along left side, some are along right side, and I have chosen in such a way so that it is the average of this thing. So your graph plotting is over. Next thing, we want to find out the slope of this graph. Okay, so slope, we will find the slope. For this slope, what we need to do, we need to draw some kind of a straight line along y-axis and some kind of straight line along x-axis. Okay, so, and this is, look carefully, I am drawing it as a dotted line so that I can distinguish between this graph, this original graph, since it is a continuous line. That means I want to make the difference between, this is the dotted line, this is not the part of, not the drawing of this graph, but this is actually the graph, and I want to find out the slope. For that purpose I have drawn this dotted line. Okay, so let's say it's a triangle ABC. Okay, so ABC, for ABC, so your slope is slope is, so slope is y by x. Okay, so slope is delta y by delta x. So delta y, that is change in this thing is BC by this is AB. Okay, so BC is how much? So look carefully. BC is this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and 102. Okay, so 102 division. Okay, and for x-axis, that is AB, delta x is how much? This is 10, 20, 30, 40, 50, 60, 70, 75, 76, 78 division. 78 divisions. Okay, these are the divisions, and you know that one smallest division along x-axis is 0.1 volt and one smallest division along y-axis is 0.25 milliampere. So that is your 102 and into one smallest division along y-axis is how much? It is 0.25. 0.25 and one smallest division along x-axis is your 78 into one smallest scale division along x-axis is 0.1. So this is the slope. Okay, so this is the slope. So yeah, and one needs to consider what is the unit. So you are showing the slope, so you need to consideration of this unit also. So unit will be along y-axis is milliampere, and along x-axis it is applied voltage in volt. So okay, so this unit is called ampere per volt. It is called mho, okay, and milli. So it is your millimho. So in this way you can plot the graph. Okay, in this way you can plot the graph and you can find the slope. Okay, so that's all.